Blackboard. I know previously you used Blackboard, but I don't know Blackboard. So go to the course website and you should be able to see the videos posted in the course website. Okay, guys? All right. Now today, we're gonna go through the tutorial, right? So the tutorial sheet for today, let me start recording first before I forget. I started recording already. Okay, the tutorial sheet for today is, let me show you. Share screen. The tutorial sheet for today is this one, right? This is the tutorial sheet. And this is as you can see from the title, it is an introduction. It's an introduction to R, where R is as I said before, R is a free statistical software. Now I will take you through this sheet in the next hour until 5 p.m. UK time, right? So the first thing you need to do is to install R. If you haven't already installed R, let me show you how to do it. So you open a browser, you open this browser, and then you type HTTP www.r-project.org, and you will go to this website, right? And then you click on download R, and it will take you to this website. This is a mirror website. It contains several different countries, many different countries, and the mirror website. So since I'm in the UK, I will choose one of these, but depending on where you are, you may not be in the UK. So I don't know, you may choose a different mirror website. In this case, I will choose, excuse me. I will choose this one, right? It will take me to this page. Now there are three options here. Depending on what operating system that you have, you can use Linux or Mac or Windows. Now I use Windows, so I will click on this one. It will take me to this. Now here, if you're installing it for the first time, you will just click on this. Right? You will click on this, and once you click, it will start installing R software to your computer, right? So that's all you need to do. It's not really difficult. I mean, it's not rocket science. Okay, so once you install the R software, let me close this. You go to the start button, right? And then you find R. This is my R, okay? And there are two versions. There's a 64 byte version, and there's a 386 version. I will choose the 64 byte, which is more powerful. All right, and it will come up with this window, right? So this is the R window that you will get. All right. If you have any questions, guys, use the chat room. So I will be able to whatever you type. Any questions you guys have, please feel free to use the chat room. Okay. Guys, the 64 byte version is more powerful, so I will choose that one, right? Okay. Now next, okay, let's go through the tutorial sheet. Right. The first thing is, like, the first thing you need to do is, like, if you want help on anything, like for example, if you want to help on for sum, you just type help sum. It will come up with the help menu. It will come up with the help window, and you'll be able to read what sum actually means. Sum is a command in R, right? And then simple things like if you want to manipulate numbers, like 34 plus 24 is 57, and minus 8 is 49, right? And if you want to multiply two numbers, say 25 times 20, you write it like 25 star 20, that will give you 500, right? And if you want to divide two numbers, then you say like this. This is a division, right? This is a division simple. And if you want the exponentiation, like 4 power 3 is 64, right? 4 power 3 is 64. And yes, the choice of country is in the mirror server location. That you are right, sir. You are right. Yeah, you're right about that, Mikhail. Yeah, and then if you want like more complex operations, like for example, if you want something like this, first it will, when you have sums and products and divisions together, it will first do the multiplication first, then the division, and then the sum. So you will get the answer 10. And pi is a number in R, and it is 3, as you know, the pi to the first 6 decimal places is 3.141593. And if you want to multiply pi by, say, 10 to the power 2, you will get this, right? Okay, so that's something. All right, then how do you create objects? How do you create objects in R? So suppose you want to create an object called A and assign the value 23. So what this operation means that you are assigning the value 23 to an object called A. So if you type A now, you see it contains the value 23. Now, if you type like this, what this does is it assigns the value 5 to an object called B, right? So if you type B now, you see it contains the value 5. So 8 times B is 115, right? A divided by B is 4.6. Now, if you create a new object, say C, say 10 times 8 times B, then C will contain the value 1150, right? So C is a new object which takes the value 10 multiplied by 8 multiplied by B, right? Now LS is LS stands for list. So it lists all the objects in the system right now. So you have created 3 objects, A, B, and C. So LS, this number key is a comment key. This is a comment. It's a comment line. So if you want to comment something, you start with the number key, right? Okay. And RM, it removes the object. So in this case, what RM means removes all objects in R, right? So if you type LS right now, you see there is no objects left in R because we have removed all the objects A, B, and C, right? So at the moment we have no objects in R. Okay. All right. Now let's create an object called 5, right? So X is 5. Now if you type capital X, it will not recognize because little x and capital X are 2 different. So in R, the case matters. I mean, whether you type small letter or capital letter makes a difference, right? So you have to be careful, right? So what is a mirror server? Sorry, mirror server is basically, guys, it contains the same version of R in different countries around the world, right? So for people living in China, they can access the files from a version in China. So it's closer. You see, the world is a huge place, right? So you don't need to, like for people living in the UK, they can access the R files from a server in the UK. The people living in, say, Africa, they can access the files from a mirror site in Africa, and so on. So it's like it's a mirror server, means it's like they have like these different sites across the world, right? So that they can access the files from the particular mirror server closest to their country, right? Okay, that's what mirror server means. Okay. All right. Now, how do you create vectors? How do you create vectors? Now, create a vector. You need, so let's say X is a vector that contains the following values: 1.4, 2.7, 4.9, 5.5, 7.8, 10.2, 14.2, 15.0, 16, right? Now X is a vector, is of length 1, 2, 3, 6, 9. So X is a vector of length 9 that contains the values 1.4, 2.7 up to 16, right? Okay, so that is how you create vectors. To create a vector, you need to start with C. You need to start with C, and then enter the numbers that you want to put inside the brackets. So C bracket, open bracket, then enter the numbers, then close bracket. That's what you need to do, right? To create a vector. Now you can do normal operations with the vector. So if you multiply 2 times X, it will multiply every element in X by 2. So you can see 1.4 goes to 2.8, 2.7 goes to 5.4, and so on. And if you say 2 times X plus 1, sorry, excuse me, I made a mess up here, so excuse me for a minute. So if you say 2 times X plus 1, it will add 1 to this vector here, right? Okay. And if you say 1 divided by X, then it will divide. So this 1.4 will become 1 divided by 1.4. 2.7 will become 1 divided by 2.7, and so on, right? Okay. And length of X is how many elements you have in X. So you see X has 9 elements. The length of X is the number of data points in the vector, right? Right. Okay. No, it's not a vector in multi-dimension. I mean, what we have here, Vincent, is a vector in 1 dimension. We will talk about vectors in multi-dimensions later on in the course, right? But no, we don't have. I mean, the vector I'm just talking about is just a vector in 1 dimension, right? No, it's not multi-dimensional. See, X is a vector of length 9. Okay. Right, now there are certain operations like length. Length computes the length of the vector. Sort of X, it sorts the values in the vector from the smallest value to the largest value. So 1.4 is the smallest, 16 is the largest value. And if you say square root X, what it does is it computes the square root of every single number in the vector X. So the square root of 1.4 is this, and the square root of 2.7 is this, and so on. And if you say sum of X, right, it computes the sum. It computes the sum of all the values in X, which turns out to be 77.7, right? And if you say mean of X is the average of all the values in X. So if you sum all the values in X and divide by 9, you will get 8.63333. And if you say var of X, it computes the sample variance of the values in X. I mean, this morning I gave you a formula for the sample variance, you may recall. So that form, if you use that formula, you will get this value, 30.0275, right? Okay. And if you want to compute, say, the square root, you can do this. All right. You can also use SD. SD stands for standard deviation. You see, both these give the same answer as they should. The standard deviation is defined as the square root of the variance. So both give the same answer, right? And now if you type ls, you have this just one x, right? Okay. Now let's retype x. Now, if you want to access a particular element in this vector, right? Suppose you want to pick the third element in this vector, then you say x in brackets 3, right? Suppose you want the last element, then you say x in brackets 9, which is 16, right? Now, if you want to remove a particular element from this vector, right? Say suppose you want to remove the third element, right? Then this will become this. You see, it's 1.4, 2.7, 5.5, up to 16. So we have removed the third element, which was 4.9. Right. Now, suppose you want all the data from 2 to 5. That is, in other words, all the data in this line from the second position to the 5th position, right? So that's what you will get: 2.7, 4.9, 5.5, and 7.8. Right. Okay. All right. Next, suppose, let me type x again. Suppose you want all the last three data points. Then you will use this command here. Remember, length of x in this case is 9, right? So 9 minus 2 is 7. So so all the data points from the 7th position to the 9th position, which are 14.2, 15, and 16, right? So these are the last 3 data points, right? Okay. Now, suppose you want the 2nd, the 4th, and the 8th data points. This is what you will get, right? These 2 points. So the 2nd data point is 2.7, the 4th is 5.5, and the 8th is 15, right? Now, suppose you want all the x values that are greater than 12. This is what you will get. So here, all the data, it lists all the data points which are greater than 12, which are the last 3 data points, right? And suppose you want x to be less than 2, yeah, or this is x to be greater than 15. Then you get this. Right, come on, stay with me, guys. Don't disappear, okay? I mean, you want x to be less than 2, or this vertical sign means or, right? The vertical sign means or. So x is less than 2 or greater than 15. So you got 1.4 or 16, right? Okay. All right, guys, are you with me so far? Okay. You have any questions so far? Hello, guys. Talk to me, guys. Are you okay or what? If you have any questions, please let me know. Thank you. Thank you, guys. Thank you. Thank you, guys. All right. Now, suppose you want all the values of x where x is greater than 6 and less than 12, right? So you will get this. So here it says x must be greater than 6 and must be less than 12. So there are only 2 data points, like where x is greater than 6 and less than 12, right? Let's retype x again. Now, there's a huge difference if you say x greater than 5, it will come up with this true false values, because when you put a command like this, what R looks for is whether each data point here is greater than 5 or less than 5. So 1.4 is not greater than 5, so it is false. 2.7 is not greater than 5, so it's false. 4.9 is not greater than 5, so it's a false. And these numbers, all these numbers here are greater than 5, so it's true. So it's either true or false, depending on whether the condition is satisfied or not, right? Okay. So if you assign this to an object LV, then LV will give these values. Now there's a huge difference between, okay, let me explain what that is. This command here, it lists all the values in X where X is greater than 5. Whereas this command, you see the difference between these two commands. Although they look pretty much the same, right? They look pretty much the same, but they are hugely different. I mean, the first command lists the values of X where X is greater than 5. The second command, it says whether X is greater than 5 or not. So if the value is greater than 5, then it's true. If it is not greater than 5, then it is false. So these two are very different. I mean, although the commands look very similar, they're actually very, very different things. They tell you very different things about X. Okay. Right. Now, okay, let's C be a C1. Let C1 be a vector, right? With two true comma true, right? Don Hin, yes, I got your command, but is there a clear all function as in to clear all commands? You can use the RM command, but that will remove all the, I'm not sure whether there's a clear all function. I'm not sure about it. So I'm sorry, I don't, I'm not, yes, Vincent, you're correct, yeah. X greater than 5 is the same as LV equal, assigned. I mean, here, when I said LV this, I meant I'm assigning this value, X greater than 5, to an object called LV, right? Right, and here, and this one is just simply saying that X is greater than 5. So these two lines they are pretty much the same. Yeah. Elliot, I'm not sure. I don't use MATLAB, so I'm not sure about it. I don't know whether it works in R. I'm not sure. Okay. All right. Anyway, let C1 be the vector containing the values true, comma true, and let C2 be a vector containing the values true and false. Right. Now, if you type C1 and C2, then you will get true and false. The reason being that true and true gives you true, whereas true and false gives you false. I'm sure you've done Boolean algebra in your first, maybe, I don't know, have you guys done Boolean algebra? You should know this kind of stuff. True and true is true, true and false is false, right? Okay, so now if you type C1 or C2, remember the vertical line means or, right? In that case, you'll get true and true or true is true, true or false also true, right? Now you should type the exclamation marks means the opposite of opposite. It means opposite of whatever whatever the the thing is, right? So the opposite of true is false. The opposite of true is also false. So it is false, right? And so on. All right. Now, let me explain that there are different like this one means less than, right, in R, right? And this one means greater than, all right, greater than in R. And then this one means this one means less than or equal to, less than or equal, sorry, equal to, right? And this one means greater than, sorry, greater than or equal to, right? And this, if you have a double equal sign, that means equal to, right? And if you have something like this, that means not equal to, right? And if you have something like, if you have this, that means and, right? And if you have the vertical bar, which is this one, that means or. And finally, if you have the exclamation mark, that means negation, right? That means opposite of whatever the thing is, right? I think in R only this will work. I don't think this will. Let me check if I don't think this will work in R. I don't know. It will not work. So you have to use only this. This means less than. William, is it William? Yeah, William. Only this will work, William. Or so this means less than or equal to, and this means greater than or equal to in R. Okay, yeah. All right, now let's go to the, there are 3 exercises at the very end of, so let me okay, let me open the tutorial sheet once again. So if you go to the tutorial sheet at the very end, see there are 3 exercises. This is exercise 1. Exercise 1 at the and this is exercise 2, and then there's another exercise which is at the end. Right, so let's do those. All right, let's start with exercise 1, right? So this is exercise 1, okay? In exercise 1, you are given 2 different vectors. So y equal to 1, 2, 4, 12, 16, right? And you have z equal to, z is defined as the vector containing 3, 4, 8, 9, 15, 18. So these are the 2 vectors that you're given. The first question is to find y minus 3, which is easy, right? So you just type y minus 3. The second question is to find z times 3 plus 1, which gives you this. The third is to find the median of, remember, median is the middle number. Median of y is 4. Median of z is 8.5. The fourth is to find the sum of all the values in z which are greater than 10. That's 33. So if you look, so if you look at, there are only 2 values in z that are greater than 10, so which is 15 and 18. And if you sum those two, you will get 33. Okay. You don't, Vincent, you don't need to give us space. I'm just doing it. There's no need to give us space, Vincent. You just, yeah. And the fifth is to find the mean or the average of the values in y between 2 and 4. So that means the values 2, 4, and 12. So if you take the average, you get 6, right? The average of 2, 4, and 12 is equal to 6. And the next part is to find the mean of the values in Z, which exclude all the right. So what I meant here is that you should look at Z, which is this one, and you should remove all the data from the 4th position to the 6th position, which is 9, 15, and 8. You should remove these 3 data points. Then the average of 2, 4, and 8 is equal to 4.66667, right? All right, that's what, and the next is Y plus Z. Y plus doesn't work. The reason being that Y and Z, they have different length. You see, the length of Y is 5, the length of Z is 6. So you can't add 2 vectors that have different lengths, right? Okay, 2 vectors of different length cannot be added. Right? That's the reason, right? Okay. And the next one is sum of Y greater than or equal to 4. This tells you how many of the Y's are greater than or equal to 4. As you can see, there are only 3 data points that are greater than or equal to 4, right? And this tells you something completely different. What this tells you is it takes the sum of the values of Y that are greater than or equal to 4. So it's 4 plus 12 plus 16 is equal to 32, right? And finally, is this. What this tells you is that how many of the values in Z are greater than 5 and less than 12, right? There are only 2 of them. You see, only two of these. Excuse me. There are only 2 values in Z are greater than 5 and less than 12. So it's mainly 8, namely 8 and 9. Okay, are the only value. Okay. Okay. So that completes exercise 1. Exercise 2. Exercise 2. Let's go to exercise 2. Now you have. Let me show you what exercise 2 is. I mean, you should know it. You can check in your computer. This is exercise 2, guys. This is exercise 2. You have daily prices from 38 to 48, right? So this is exercise 2. Okay. All right, guys. So let's try to do exercise 2. So let's say S. I will show you in a minute how to find the min and the max. To find the min, excuse me, to find the min, you just compute min of x. That's the easy. To find the max, you just say max of x. That's easy. That's how you find the minimum and the maximum, sir, right? Now, why, Vincent, you're asking one more time, why sum of y? That's because, look, if you look at y, there are 3 values that are greater than or equal to 4, right? So that is why the sum of y greater than or equal to 4 is 3. That's because it's the number of data points that are greater than or equal to 3, Vincent. All right, so which in this case is 3, right? The number of data points greater than or equal to 4, which is 3 in this case, right? Okay, I hope you guys follow that. Guys, please stay with me. All right, let's try to do exercise 2 now. All right, so define S as 38, 42, 44, 43, 46, 48, 52, 54, 50, 47, 48, 48. So this is the This is the data that is given to you in exercise number 2. Now, to find the minimum, you just type min of S, right? To find the maximum, you just type max of S. To find the range, remember, the range is the difference between the minimum and the maximum. You just type this, right? To find the mean, you just type mean of S. To find the standard deviation, you just type SD of S, right? Okay, so it's easy. Now, in part three, guys, we want to correct the first value, which is currently 38, to be equal to 48. The easiest way to do that is, we know that the first value is 38 now, but we want it to be equal to 48. So what you need to do is simply this. Now you see S is now corrected with the first value equal to 48. Now, based on the corrected data, the next part, based on the corrected data, find the percentage of days with the price less than 45 pence. So you need to, the percentage of days. So this, excuse me, this is S less than. This gives you the number of days when the price is less than 45, right? And you need to divide this by the total length of the data, and then you multiply it by 100. So the percentage of days, where the price was less than 45 is 25%. You see what I've done. This is the number of days, right, when the price was less than 45, right? And this is the total length of S gives you the total number of days, right? And then you multiply it by 100, okay? Now, final part is to use the diff. Now, S, this is the S. Now, to do diff, what the diff command does is it takes the difference between successive values. So, for example, -6 is the difference between 42 and 48. The difference between 44 and 42 is 2. 43 minus 44 is -1. 46 minus 43 is 3, and so on. Right? So the length of the diff is always 1 less than the length of S. So if you type length, of diff, you will get 11, right? Which is 1 less than the length of S, which is 12, right? Because of the way that you compute the differences, right? It's always 1 less, right? All right, next is how to read data into R. Suppose are you guys okay so far, by the way? Any questions? No. Or yes or no? Are you okay? Okay, thank you, guys. All right, thank you. All right, now let me show you how to read a data file into R, right? So you got to the course website, which is this one. Suppose you want to read this data, right? This is the Moses data, right? And you have all these data points. All you have to do is this: just copy the URL. So copy, right, and then paste it here. All right, and then you say read table, read dot table. Put this in quotes, right? Put them in double quotes, and then you put header equal to true. The reason you put header equal to true is because if you go back to the data, you see the data set has a header, right? Time is the header, right? So you don't want to read the header, so that's why you put header equal to true. Right, now you should call, let's call this Moses, right? Okay, so that we have read the data, right? Now you should type Moses, you will see this data. The first column is just the counter column. The second is the actual data. So there's the time, which has the title time, right? Okay, so if you type Moses $time, it picks up the data. It picks up the data that you just read, right? So this is the data that you just read, right? Okay. Now categorical data. I mean, you can do like statistics, like find the minimum and the median and the maximum. So the minimum value is this, the maximum value is this, and the mean is this, the median is this, and the sample variance is this, and so on. So you can compute all kind of stuff using simple commands, right? Right, now the next thing I want to do is to, it's also asking what proportion of the times are less than 47.5 seconds. So to compute that, all you have to do is just Moses time less than 47.5, right? Okay, and then you compute the length of this, right? And then you divide this by the length of the Moses time, all right? So it gives you the proportion of the times when the time was less than 47.5. And it is also asking you for the proportion of times when the time was greater than 49.5, which is this one, right? All right, guys, so that's on the Moses data. Now, about categorical data. To categorical data, you can have like yes or no, right? You can have yes or no kind of data for categorical. So suppose you have this data. Okay, suppose, let me type this in, all right? Just take me a while. I'm slow typing this. I'm slow typing stuff in, as you can see. So this is a categorical data. When you have yes or no data, it's known as categorical data. So if you type response, you will see the data that I just typed in, right? And if you type table, it will give you a summary of the data. So it says there are 8 responses saying no and 7 responses saying yes, right? And you can also create a factor variable using this command. So you should now type response F, right? You will see this is a factor containing either yes or no answer, right? Okay, and if you type levels of the factor using this command, once again, you see there are 2 levels, either yes or no, right? And you can change the levels to whatever you like. Like, for example, if you want to call it, say, instead of yes or no, suppose you want to call it 0 or 1. So 0 for no and yet 1 for yes, right? Then you use this command, right? Now you should type levels. You should type levels again, you get 0 or 1, right? And if you type response F, you will get 0 or 1. So 1 corresponds to yes and 0 corresponds to no, right? Okay, and finally, it's on page 9 of the exercise sheet. It is asking you to read the following data set. So if you go to the website, this is the website, this is the data set. So it is asking you to read this data. So you copy, what you do is you copy it, you copy the URL and you go back to R, right? Go back to R and paste it. Sorry, excuse me. Paste it, right? And then say read table. Read table in quotes, and then you say header equal to true. Excuse me, sorry. Header equal to true, right? So this will read the data. Let's call this polls or something. Okay, let's call this polls, and then it's asking you to record the values into party names, right? So what you need to do, is just use learn what is to. Okay, let me first type polls, right? Let me first type polls. So you get two different columns. The first column is just simply the counter column, and the second column is just simply the party column, right? So if you type polls $party, it contains these 5 different digits, 1 to 5, depending on which party people voted for, right? Okay, now if you type levels equal to, excuse me, levels equal to this. Sorry, first of all, I need to convert this into a factor. Let me convert this into a factor. Okay, once you've done this, then you type levels of polls F. It has 1 to 5. Right now, suppose you want to record the levels into something more meaningful, right? Like 1 stands for conservative, got the Conservative Party. 2 stands for Labor, right? 3 stands for Liberal Democrats, right? And 4 stands for UKIP, and 5 stands for other, right? So now you can record the data in terms of the actual names of the parties, right? This is, then you should type now polls F, right? This is what you will get. So these are this is the data now recorded in terms of the actual names of the parties, right? Okay. All right. So this completes the tutorial sheet 1. Any questions, guys? Hello, guys.
No questions.
Okay, thank you, guys. So I will. Okay, there's another. I will talk to you soon. Any problems you guys have? Any problems you guys have? Just send me an email. Okay. Thank you, guys.
Thank you, Israels.
Yeah, my pleasure. Have a great evening wherever you are. Mm -hmm. there should be a way to save the work in R, but I'm not sure exactly how. You should check the internet. I mean, if you do a search in Google, you should figure out how to do it. I'm not sure exactly how to save things in R. Okay. Uh, yeah, but you should be able to figure that out in the Google. You should just type in Google. You should be able to tell you. Google should tell you how to do it. Not sure. Good evening, guys. Hope you are well. All right, guys. Good evening, guys. So this is a tutorial session. Before I start the tutorial, let me tell you something. The review session that we had this morning, the videos from that have already been posted in the course website. So if you go to the course website, which is this one. Just a minute, guys. You should go to the course website, which is, excuse me. If you go to the course website, which is this one, you will see these two videos which have been just added this afternoon, right? So this video gives the YouTube version of the review session this morning, and this is the UOM version of the review session this morning. Okay, so you should be able to see the videos from these two, and this is the handwritten notes from the review session this morning. Okay, guys. Okay, so the purpose of this session is the tutorial. So I'm gonna go through the tutorial sheet for today, which is this one. So this is the tutorial sheet for today. It's about introducing you to R. R is a free statistical software. I think I mentioned this before. So I will take you through this website. I will take you through this sheet in this 1 hour we have. Okay. All right, guys. So let's begin. Now the first thing you need to do is to install R. I mean, I already have installed R, but you may not. So to install R, you need to open a browser. You need to open a browser, right? And then type r-project.org, right? And it will take you, just a minute, things are slow here. It will take you to this, right? And then click on R, okay, and it will take you to this. These are mirror websites. Mirror website are basically like website containing the same material but in different parts of the world. Since I am in the UK, I will go to the UK site, which is this one, right? And you will get to this. There are 3 links here. You can, depending on the operating system that you have, if you have a Linux, you will click on this. If you have Mac, if you have a Mac operating system, then you will click on this. If you have Windows, you will click on this. So I have Windows. Now, if you're installing R for the first time, you just click on this and then follow the links, right? Okay, so I'm not going to do that because I already have R in my computer, right? But if you don't have R, then just click on this and follow the links, and it's pretty straightforward to install, right? Okay, let me now close the window. Now, once you install R, then you click on the Start button, right? And then you go down here and choose R, which is this one. There are 2 different versions. You should choose the 64-byte version, which is 64-byte is more powerful than this one. So I'll choose the 64-byte version. Okay, and this is what you will get. So this is the command window for R. Okay. Okay, now let me take you through this tutorial sheet, which I'm sure you have a copy of it with you. Right now, if you want help on anything, like for example, if you want to help on, say, mean, for example, right? So suppose you want to know what mean means, right? You can just type help in brackets mean, and it will come up with a window explaining what mean actually means, right? Okay. Okay. Yeah, 4.03 is okay. 4.03 is fine. Is fine. I mean, that's the latest version, I think. So that's the 4.0.3 is the latest version. So that is fine. Yeah. Okay. Right. Now, if you want to like do simple summations, so suppose you want to add 2 numbers, 33 and 24, you just type 33 plus 24, and minus 8 is 49. Suppose you want to multiply 2 numbers. This is what you do. All right. Suppose you want to divide one number by another number, right? And this is what you will do. And suppose you want to say exponentiation. Say 4 power 3 is 64. 4 raised to the power 3 is 64. Now, suppose you want to do something more complicated, like the following, right? Here, I mean, there's an order for this operation. The first operation is multiplication. The second operation is division, and the third operation is the summation, right? So that's how it works. I'm sure you know this, right? And there's also a number called pi in R, which takes the value. I'm sure you guys know what pi is, right? And you can multiply pi by anything. Say, for example, pi multiplied by 10 to the power 2 is this, right? Right. Now, all right. Now let's see how we can create objects. So now, objects in R can be created using this arrow key and backward arrow key, right? So this will create an object A containing the value 23, right? And this will create an object B containing the value B, right? Containing the value 5, I mean 5, okay? So for example, if you say A times B, that will be 115. If you say A divided by B is 4.6. And you can also create other objects like C equal to 10 times A times B. C will be 100,150, right? And the command ls stands for list. So ls means lists. So it basically lists all the objects in R, right? So ls stands for list. By the way, the number key, this is a number key. It's used for comment line. Comment is a comment line. So you can write anything but the command that you're doing, about what it means and so on, okay? And the command rm means remove. So if you say rm removes all objects in R session, right? So if you now type ls, see there's no objects left because you have removed all the objects, right? Daniel, yes, they are the same. Yeah, you're right. I mean, A23 is the same as A23. They are both the same. Yeah, but people prefer to use the backwards arrows operation than the equal sign. I know you may find equal sign better, but in our tradition, traditionally, people use the backward arrow operation. Okay, all right. Next, case sensitivity. Now, suppose you type x. Suppose you type x equal to 5, right? So x takes the value 5. Now, suppose you type capital X. It's undefined, right? That's because R is case sensitive. So small letter and capital letter, they are two different things. So little x and capital X, they are two different things. Okay. All right. Now, how to create vectors? Now, if you want to create a vector, use this command C open bracket, and then you type in the numbers. Okay, so this, you see what I've done here? I have created a vector containing the values 1.4, 2.7 up to 16. There are 9 values in this vector, right? Okay. And you can do standard operations with the vector. So for example, 2 times x, it multiplies every single element by 2. 2 times x plus 1, it adds 1 on top of it, right? 1 divided by x is the reciprocal of every single value in x, right? And there are standard commands with the vector. So length gives you the length, how many elements you have in x. Yichen, yeah. See, this means is a vector, right? This command is used to create a vector. Is create a vector. So if you type C 2, 4, 6 like this, right? It creates a vector containing the numbers 2, 4, 5, and 6, right? So that's what it means, right? So that the okay. Now you should type sort of x. You have this x here. This is x, right? You should type sort x. What it does is it arranges the data from the smallest to the largest. So you see, this is the smallest data. This is the second, third, fourth, and up to this is the largest, right? And if you type square root of x, it takes the square root of every data in x. If you type sum of x, it takes the sum of all the values in x. So if you sum all the values in x, right, you get 77.7. If you type mean x, it takes the average. So this is the average of all the data points in here, right? and if you type var of x, this is the variance. This is the variance of the data in here, right? And if you type st of x, that's the standard deviation, which is the square root of the variance, right? Okay. In fact, you will get the same answer. Now, if you take the square root of the variance, you see this is the same as this because they should be, right? The standard deviation is the square root of the variance, so they should give you the same answer, right? Okay. All right, now let's retype x. Now let's suppose you want to pick a certain element of x. So suppose you want the third data point, right? Then you type x3, right? You see it gives you the third data point, right? Suppose you want to remove the third data point, then it gives you this. You see this here, what you see here is the same as this, but with the third data point removed, right? And suppose you want only the data points from the second to the fifth positions. So this is 2, 3, 4, 5. So these values. So you get this. You see 2.7, 4.9, 5.5, and 7.8. Okay. And suppose you want only the data from on the second, fourth, and eighth positions of x. So the second position is 2.7, the fourth is 5.5, and the eighth is 15. So it gives you these values, right? Now, suppose you want all the data in x which are greater than 12. So these are the three data points which are greater than 12, right? So there's 14.2, 15, and 16. Now suppose you want x less than 2 or x greater than 15. And the vertical bar here means or, right? The vertical bar means or. So here you're asking x is less than 2 or greater than 15. So once again, there are only two data points, right, that satisfy this criterion, 1.4 or 16, right? Now suppose you want x to be greater than 6 and less than 12, right? Once again, there are only two data points where x is greater than 6 and less than 12, right? So it's namely 7.8 and 4.2. Now let me retype x again one more time, okay? Now suppose x is, you type this, right? In this case, what you're asking is whether x is greater than 5 or not. So it checks if every single element here is greater than 5 or not. 1.5 is not, 2.7 is not, 4.9 is not, and the rest are greater than 5. So you get false, 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 and the rest are true, right? Okay, you can assign this to an object called LV, and if you type LV, you get the same result, right? Now, there is a huge difference between this command and this command. You see the difference between these two. The first command, which is this one, it lists all the values in x which are greater than 5, right? Whereas the second command, right, it checks whether the values in x are greater than 5 or not. So these two are, although they look similar, they are very different. You see, so you have to be careful. So the first one, it checks whether x, it finds the values in x that are greater than 5. And the second one checks which values in x are greater than 5, right? And if they are, then it's true, otherwise it's a false, right? All right, then there are certain commands I need to describe. This means less than, right, in R, right? And this means greater than. And this means less than or equal to, less than or equal to. And this means greater than or, sorry, equal to, right? LV is just a variable, John. Is that John? Yeah. LV is just a variable. So it's like an object, right? So I'm assigning x greater than 5 to an object called LV. You can call it any other name. I mean, it doesn't need to be LV. You can call it whatever name you like, right? And a double equal sign means equal to. And if you put an exclamation mark and equal, that means not equal to. Okay, and if you put this sign, that means and. Okay, and if you put the vertical bar, that means or. And finally, if you put like an exclamation mark, that means negation, right? Or the opposite of. Okay. Now suppose you have a vector with two elements, true. Sorry, excuse me. True, comma, true, right? And suppose you have another vector with, say, true and false. Okay. Okay. Then C1 and C2 will be true and false, because I'm sure you've done Boolean algebra, so you know like true and true is true, and true and false is false, right? Okay, and whereas C1 or C2 will be true and true, because true or true is true, true or false is true. Okay, that's, I mean, standard Boolean algebra. I'm sure you know better than I do, right? And if you type exclamation marks and C1, that will be false, because the negation of true is false and the negation of true is also false. So it is false and false, right? Okay. All right. Now let me, if you go to page 6 of the tutorial sheet, right? Let me show you. Let me close this for a minute. And am I recording? Let me check. Just a minute, guys. I am recording. Okay, sure. I just wanted to check if I'm recording it. Okay. Okay, guys. So if you go to page 6 of the tutorial sheet, which is this one. Yeah, this is the tutorial sheet. Page 6 is this one. There are two exercises that we need to do. This is exercise 1. This is exercise 2. So let's do them right now. Okay. Close. So let's start with exercise 1. If you have any questions, just feel free to use the chat room. Okay. Exercise 1, guys. Okay. So the first, we need to create two vectors, y. So y contains the numbers 1, 2, 4, 12, 16. And z contains the numbers is 3, 4, 8, 9, 15, 18. All right. Okay. Now let's see how we can do it. Okay. The first part is to compute y minus 3, which is easy. So it just takes away 3 from each element of y. The second part is to multiply z by 3 and add 1. The third part is to find the median of y, which is this one, right? And the median of z, which is this one. And the fourth part is to sum the values in z which are greater than 10. Okay, so that is 33. So if you look at z, guys, here, there are only two numbers here that are greater than 10, 15 and 18. And if you sum them, 15 plus 18 is 33, right? Okay. And the next part is to find the mean of y between the second and the fourth position. So you get 6. The reason for that is because the second data point is 2, the third is 4th, and the fourth data point is 12. So if you take the average, you should take the average of these 3 data points, you get 6, right? Okay, guys. And then the next one is about z. Okay, let me type z first. This is z. So if you type z, mean of z, you get this. You see, what I've done here is to take away all the points between the 4th and the 6th. So remember, the 4th position is this, then the 6th position is this. So you remove all these data points, these 3 data points. So you're left with 3, 4, and 8. And the average of 3, 4, and 8 is 5. Okay. And the next one is y plus z, which is undefined, because the reason they are undefined is because y and z are of different length. I mean, so because y and z are of different lengths. So you can't add two vectors that are of different length. It's undefined, all right? So that's why y plus z is undefined, okay? Now the next part is sum of y greater than or equal to 4. Greater than or equal to, I'm sorry, is 3. That's because there are 3 data points. There are 3 data points where y is greater than or equal to 4. So that's why this is 3, right? Whereas this command here, this command will give you 32, because what it does is it takes the sum of the values in y that are greater than or equal to 4. So it sums these 3 data points. 4 plus 12 plus 16 is equal to 32, right? And finally, you have z. If you do sum of z greater than 5 and z less than 12, you get this, right? So the reason for this is because what it does here is it looks for how many of these data points are greater than 5 and less than 12. So it's basically there are only 2. There are only 2 data points that satisfy these 2 inequalities, right? And therefore the answer is 2. Okay, so that completes exercise 1. Now let's go back, let's go to exercise 2. Exercise 2 is, by the way, any questions on exercise 1? Hello, guys. Any questions on exercise 1? You like? No? Yes, no? Okay, thank you, guys. Thank you. All right, now let's go to exercise 2. Exercise 2 is you have this data on closing prices. And there are 5 different parts, all right? So the first thing you need to do is to type in the data, exercise 2. So I'm going to type in the data, let's call it S, right, which is going to be 38, 42, 44, 43, 46, 48, 52, 54, 50, 47, 48, 48. All right, so this is the data. Okay. Part 2 is to find the minimum, maximum, range, mean, and standard deviation. Okay, to find the minimum, you just use the command min. Min finds the minimum, right? Max finds the maximum. Range is just the difference between the minimum and the maximum, which is 16. Mean, to find the mean, you just type mean, S, right? To find the standard deviation, you just type SD, right? So it's really easy, right? So this is the minimum, this is the maximum, range, mean, and the standard deviation. All right, the next part, it tells you that the first value, which is 38, should have been 48. So how do you correct? So remember, this is the first value, S in brackets 1. Now we want this corrected to 48. So the easiest way to do that is simply this, right? You see what I've done? I have used this command here. The first value, assign the value 48. So S becomes this, which is the new data set, with the first value being equal to 48, right? And the next thing is we want to find the percentage of days when the closing price was less than 45 pence. All right, so we are looking for S less than 48, right? And we want to find the length of this, right? And then we want to divide this by the length of S and then multiply it by 100. You see what I've done? So this, oh, did I do it correct? Less than 45, sorry, not 48. It should be 45. Sorry, guys. So you see what I've done? This command here gives you the number of days when the closing price was less than 45. And this is the total number of days, right? So you divide this by this and then multiply by 100. It gives you the percentage of days when the closing price was less than 45. Finally, the diff command. This is S. Now, if you type diff of S, what it does is the following. You see, the difference between 42 and 48 is -6. The difference between 44 and 42 is 2. 43 minus 44 is -1. 46 minus 43 is 3, and so on. So it takes the difference between successive values, right? So the length, the length of this vector, the diff vector, is always 1 less than the length of the original vector. So for example, so you should type length of diff, you will get 11, right? Whereas the length of the original vector was 12, right? Because of the way it computes it, the length will always be 1 less than the length of the original vector, right? So that completes exercise number 2, all right? Any questions so far, guys? Let me know, please. Okay, guys, thank you. All right, the next thing we need to learn is how to read data. Now, if you go back to the course website, this is the course website. There is a data set. There are 2 data sets. The first one is called Moses data, and it gives you the time. It gives you the time in seconds for a certain number of data, a certain number of people, right? Okay. Now, how do we read this? To read this data, what you need to do is this. You just copy the URL, right? Okay, and then you go to the R session and paste it, right? And then you issue the command called read.table. And and you put this in quotes, and then you say header equal to true, right? The reason I put header equal to true is because if you go to the data set, it has a header which is called time. So you don't want to read the header, so right? So for that reason, I put header equal to true. Okay, now you need to give a name for the data. Let's call it Moses, right? So this will read the data. Now, if you type Moses, you will see this data. You see we have read the data. The first one is the counter column. The second one is the time column. The counter column you can ignore, and the time column is the one we need, right? So for example, if you type Moses $time, this is the data that we just read, right? Okay. All right, now it's asking you to compute the minimum, median, and the maximum. All right, so to find the minimum, you just type min. Okay. Oh, I've got a question here. Just a minute. Wait a minute, guys. Well, the reason I've used header equal to true is because just to tell the computer that the data file has a header, right? That's what. That's why I said that, Ahmad. That's because just to tell R that the data file has a header, right? Okay, that's all. All right. Hope you follow. And now you should type max. It gives you the maximum, right? You should type mean. It gives you the mean of the data. You should type median. It gives you the median of the data, and so on. Now, we are also asked to find the proportion of times less than 47.5 seconds. To do that, you proportion of time was less than 47.5, right? So you just compute the length, right? The length of this and divide this by the length of Moses. Right, so this is the proportion of times that the time was less than 47.5 seconds. And the proportion of times that the time was greater than 49.5 seconds is this, right? Okay, so this is the proportion of times that the Moses data dollar time was greater than 49.5. All right, that's the on the data. Now, categorical data. You should go to page 8 of the tutorial sheet. You will see the categorical data. Categorical data is basically, it's like a named values. So for example, a data containing yes or no is a categorical data. So suppose I guess yes, no. Let me type this in. Just give me a sec, guys, okay? I'm just typing, I'm slow typing things, so just bear with me, okay? So like whether you smoke or not, that's a categorical data because people either smoke or people do not smoke. So it can be either yes or no. Whether you drive a car or not, it can be yes or no, and so on, right? All right, so this is response, right? So if you type response now, you will see this is the data that I just typed in, right? Now, if you type table, table is a command to summarize response. So here you have 8 responses saying no and 7 responses saying yes, right? Now, another thing that you can do is to convert the response into a factor using this command, factor, right? Okay, now you should type response F. It is now a factor, right, with either yes or no, right? And you can check the levels of the factor by using this command, levels, right? So it contains either no or yes as the levels. And you can also change the levels. You can change the levels to something else. Like suppose you want to call no 0 as being no and 1 as being yes. So you can do this, right? Now you should type response F. You should not type response F. It will only contain 1 or 0. So 1 here corresponds to yes and 0 corresponds to no, right? Okay, and finally, you should go to the last page of the tutorial sheet. Let me show you where it is. The last page of the tutorial sheet is asking you to read the data, this data here. This is the opinion poll data set, right? So I'm going to read this data. So I first copy the URL, right, and then go to R, paste it, okay, and then I type read.table, okay, and let me call this poll. Okay, let me call this poll, and let me say header equal to true one more time. The reason I've said header equal to true is, once again, you should go to the data set. You see the first row has a header, right? So you should say the header is true, that there is a header for the data. All right, so that's the reason I call it header equal to true, right? All right, so this will read the data, right? Now you should type poll. This is what you get, you see. You see this data. Right, there are 2 columns. The first one is just a counter column, you can ignore. The second column is the party column, which party the people voted for. So the party is coded as a number from 1 to 5, 1, 2, 3, 4, or 5. Okay, so you type poll $party, you see this data, right? Now, suppose you want to convert these numbers into actual names of parties, right? Now, how do you do that? Right, to do that, you do this, right? The first thing you need to do is to convert this into a factor. All right, so let's call it poll, sorry, POLLF. All right. Now you should type levels of poll F. You see there are 5 different levels, right? 1, 2, 3, or 4, or 5. Now suppose you want to convert this into the actual names of the parties. So the one corresponds to Conservative, the Conservative Party in the UK, right? 2 corresponds to the Labour Party in the UK. The 3 corresponds to the Liberal Democrats, right? The 4 corresponds to UKIP, the Independence Party, and the 5 corresponds to other. Right? Okay. Now you should type polls F. You will see the data recorded as in terms of parties, not numbers. Right? So wherever there is a 1, I still do not understand what is the meaning of header truth. Could you write the reason for me later? I'm happy to write it now. Okay, let me finish this now. As you can see, the 1, 2, 3, 5 have been recorded as the actual names of the parties. either conservative or Labor or Liberal Democrats or UKIP or other. Right now, you should do a table. You should do a table of this. It tells you how it gives you a summary of the data. Right? It says there are 369 voted for Conservative, 314 voted for Labor, 75 for Liberal Democrats, 180 for UKIP, and 124 for other. Right? Okay, now let me explain. All right, let me explain what some people are still asking me about this. Header equal to true means that the data set has a header. It simply means, all right, let me type it in. Header means that the data set has a header. That's what it simply means, right? So if you go to the data set on polls, which is this one, this is the data set on polls. You see that there's a header for the data set, right? So that's why when I type the command, when I type the read command, read.table, I need to say that header equal to true, right? And dollar means that which column you want to pick. Like when you say poll, this is the data that you have, right? This is the data that you have. So if you want to pick this column, right? If you want to pick this column, which is the second column, you have to say poll dollar and the name of the column, right? So that's so it knows which column to pick, right? Okay. Like you should have more than, like in this case we only have 2 columns, but suppose you have like 5 or 6 different columns with different labels for each column, right? Then if you want to pick a certain column, you need to say dollar and then the name of the column, right? Any other questions, guys? So hello guys, talk to me. You have any other questions you want to ask? So we have gone through the tutorial sheet 1, and if you have any questions, feel free to ask me now. How to save? I still haven't figured out how to save. I know I don't know, somebody asked me this morning, but I haven't figured out how to save. But I think there is something called here. Yeah. You should go to file. You should go to file menu, and then save. You can save it to a file. Like, okay, that's easy to do. Yeah. So you go to file and save to file, or you can save also workspace. You can save a workspace as a .r data file. So there are, yeah, it's simple. I mean, you go to the file menu and then choose save workspace, right? You can also save as a file if you wish, right? Or you can also save the history. So there are several different ways you can do it. Yeah. I don't put anything. I mean, I said this. I'm recording this. At the moment I am recording this session, and I will put a recorded version of this session in the course website. So if you go to the course website, guys, I don't put anything on on Blackboard. So you will see in half an hour or so, you will see that I will post the video of what I just recorded in one of these, right? Okay. Yeah. So I don't use Blackboard. So sorry, I only use Blackboard for assessment, guys. I don't really like Blackboard. So so you just please keep checking the course website, which is this one, and within a half an hour or so, you will see a link containing the video of that one, the one I just did right now. Okay. Yes, the header equal to true means that, yeah, there is a header. Yeah, it just means there is a header to the data set. So like this data set here has a header, right? And this data set also has a header. I mean, most data sets have headers. So you have to say, when you read it, when you read the data set, you have to say header equal to true, right? Okay. That's in the review session, right? The review session we did this morning. When you have a Bernoulli distribution, the correct formula, the one I gave is the correct formula, because remember, the Bernoulli has only one or zero. There is no n in the Bernoulli. So the formula I gave, you should read it. There's no n. The Bernoulli has only one data point, which is either is equal to 1 with probability p and 0 with probability 1 minus p. So the probability mass function for the Bernoulli should be what I wrote down this morning, which is 1 minus p times 1 minus p power this. This is the PMF. This is the PMF of Bernoulli this morning, right? Because there's no n in the Bernoulli, right? There's no n in the Bernoulli. Is the binomial has an n, but Bernoulli has no n, right? Okay. All right. Any other questions, guys? Feel free to ask me, or I mean, you can contact me 24/7 by email, by phone, by Skype, by Zoom, anything. So yeah. And if you are in Manchester, I'm happy to see you too. I know some of you are not in Manchester. I guess, I don't know, most of you are not in Manchester, I guess, but if you are in Manchester, I'm happy to see you in person. Okay. Okay. All right, guys. So I will talk to you later. I think the time is already. So I'll talk to you later, guys. And as soon as possible, in the next half an hour, I will post a copy of this video on this website. Okay. All right. Have a good evening wherever you are, and I'll talk to you soon.